Hello everyone, in this video I'm going to be going over hybridization as well as sigma and pi bonds. So just really quickly, what is hybridization? So hybridization is basically when we have to make hybrid bonding orbitals, and those hybrid bonding orbitals have like a specific name to them and numbers and things like that. We're only going to be focusing on carbon in this video because that's all we're going to be tested on. And also that's all you're gonna have to know. Like I'm in the middle of taking Gen Chem 2 right now. I've already taken Orgo 1 and 2. Might need it for inorganic, not exactly sure, but up until now I've already taken Orgo 2. You only need to know the hybridization of carbon. So it makes sense as to that's the only one that we're focusing on. So what sigma and pi bonds are, sigma bonds are the first bonds between two atoms, and pi bonds are any following bonds between two atoms. I will go into more depth, showing some examples of that, but just for generalization, that's what those two mean. So let's take a look at hybridization. So hybridization, as I said before, are hybrid orbitals made for bonding. In carbon, it seems a little bit difficult to get at first, but there's a really simple way to think about this, right? So if we have something, once we draw our Lewis structure and everything, where we have a carbon with 4 things around it, that means that we're going to need 4 orbitals, or 4 hybrid orbitals. So how we can figure that out, it's always going to be, S is always going to be 1, S is never going to be S2, at least for carbon, and then P, we're going to figure out how many p's we need, whether it's 1, 2, or 3, in order to get to that number of orbitals that we need. So we're always going to start with S1, and let's say we need 4, so that means that 4 minus 3, that means that P has to be 3. So it's going to be SP3 is going to be our answer there, and that's because 1 plus 3 is 4, and that's how many orbitals that we need. Same thing with the next thing. We have carbon with a double bond and 2 single bonds, which means that we're going to have 3 orbitals needed because there's 3 things that we're attaching to the carbon. So with that being said, again, we're going to start with S1, then we're going to figure out what else we need to get to 3. So S1, P2, that's going to give us SP2, and that'll equal 3 and give us those 3 orbitals that we need. The next one, either something that is doubly bonded to carbon twice, or something that is triply bonded and then there's a single bond. With both of those, we're going to need 2 orbitals because there's 2 things attaching to that carbon. So same thing, we're starting with the S1. We're going to add that to whatever we need to get to those 2 orbitals that we need, which would be just P1. So our answer is just going to be SP. You don't write the 1 because anything with an exponent to 1 is just that thing. Same thing as like 1 to the power of 1 is going to be 1, 100 to the power of 1 is just 100. So we don't write out that exponent there. So it's just going to be SP1, and that's that 2 orbitals that we need. And that would be our answer there. So pretty simple way of thinking about it. Let's go through a little bit of a practice problem. So for hybridization, let's find the hybridization for each carbon. So I'm going to go through them one by one. I have each of them labeled. Feel free to pause and try this out yourself. But for the first carbon, I can see that there's 4 things that we need to attach to it. So we're going to do S, and what we're going to need to get to 4 is 3. All right, next one. We're only going to need 2 orbitals here because we only have 2 things attached to that carbon. So it's going to be just SP. 1 plus 1 is 2. The next carbon is the exact same situation, so I'm just going to write that there. The next one, we have 3 that we're going to deal with, so it's going to be SP2. Again, 1 plus 2 is 3, and that's what we need. Next one is the exact same situation, so we have SP2. And I believe the next one is also the exact same situation where we have 3, so again, it's going to be SP2. And that would be your answer then. So pretty simple. Okay, moving on, let's talk about our how to determine the single bond, double bond, triple bond, and sigma and pi. I have everything color organized here, so hopefully it's a little bit easier to understand. So with single bonds, we're going to count the number of only single bonds present. So when I say only single bonds present, that means that if you have something double bond, we're not going to count that. Single bond, yes, we're going to count that because that's something that is only singly bonded. If it's a triple bond, no, we're not counting that towards our single bonds. So only the things that are single bonded will be counted. Our double bonds, same situation. only the number of double bonds present. The number of only double bonds, right? So if something's double bonded, we're just going to count that because that's only double bonded. It's not single bonded, it's not triple bonded. If something's single bonded, we're not counting it. If it's single bonded or triple bonded, we're not going to count that as well. Same thing with triple bond. Number of only triple bonded things present. So if it's a triple bond, you're going to count that. If it's a single bond, we're not going to count that. And if it's double bond, we're not going to count that. So only the things that are triple bonded. So sigma and pi is where it gets a little bit confusing. But what sigma bonds are is they are the number of first bonds present. So with each bond, let's say we're looking at this. So an atom to an atom, that's a sigma bond. An atom double bonded to an atom. Only one of these is going to be a single bond because one of them has to be the first bond present, right? Doing an atom triple bond to an atom, there's only going to be one sigma bond present. So in each of these, there's going to be one sigma. Because the first bond is always going to be sigma. Now pi. Pi is the number of bonds beyond the first present. Yeah, beyond the first present in between a bond, right? So the first one we're looking at, there's not going to be any pi bonds because there's only a first bond present. In the second one, there's 2 bonds present, so this one is going to be our pi. It's going to be 1 pi. And this one has 3. The first one was sigma, so the rest of them are going to be pi. Okay, so let's run through an example here. I forget what this is. I should know that. But we're just going to look at this one, and we will be using that as our example. So our single bonds. Number of any single bonds present. So this is a single bond, and this is a single bond. That is not a single bond, so we have 2 single bonds. Double bonds, let's take a look at those. We have 1 double bond here. That's not double and that's not double, so 1 double bond. And let's take a look at our triple bonds. I don't see any triple bonds in there, so we're going to say that there's 0 triple bonds. All right, sigma. Sigma is going to be the first bonds present, so this is a first bond present, that's a first bond present, and this is a first bond present. So we're going to have 3 first bonds present. How I also count them quickly is if there's a long chain of them, I just count how many bonds there are in general present, right? So we can go 1, 2, 3. And that's how many sigma bonds that there are. Now, let's look at our pi bonds. Where's green for that? So our pi bonds are any number of bonds beyond the first. So this one, there's only only 1 present, so that's not going to have a pi bond. There's only 1 present there, so that's not going to be a pi bond. Here we have 2. The first one was sigma, so that means that the second one is going to be pi. So we only have 1 present there. Alrighty, so let's move on and take a look at this. So this will be our final problem. We're going to put everything together that we just learned. So we're going to have HCN. So C is going to be our center. And it's going to look something like that. All right, so let's determine the number of single bonds that we have. I only see 1 single bond, so I'm going to write down 1. Our double bonds, there's no double bonds, so 0. Triple bonds, there's 1 triple bond right here, so that's going to be 1. Our sigma bonds, we have 1, 2. And our pi bonds, we have 3, oh, not 3, 1, 2. So we have 2 pi bonds. And then the hybridization of the carbon. So we know that there's 2 things attached to it, so that means that the carbon is going to have to get 2 orbitals. So that means that it's going to be sp, because 1 and 1 is going to equal 2. So we will write sp. That's the answer. So you can kind of run through these pretty quickly once you know those basic steps and you kind of have a little bit of a shortcut there. But yeah, so I hope that this helps, and thank you all for watching.